Hello, everyone. This is Group 17, and our project was an AI-based decision system for improving rice crop yield and quality in Uganda. The group members are Ambanjira Mark, Bitegeka Bridget, Arinda Sophie, and Otim Nathan. Our presentation will begin with an introduction.
So I'm Bridget, and I'm going to talk about the background of rice. Rice is one of the oldest and commonest crops in Uganda. It was discovered in 2500 BC, and it's mainly grown in wetlands and various land varieties. It was introduced in Uganda in 1942 to feed the World War II soldiers. Its production increased with the construction of the Doha rice scheme in 1976. The increasing popularity of rice is due to dietary plans, urban communities, and young generations. Rice is commonly farmed in eastern regions of Uganda, as you can see on the map, and it is of two types. There is that one which is grown on the lowland, and the other one which is grown on the upland. The different rice varieties offer variations in yield rate, resistance to pests and diseases, and cooking properties. Nerica varieties is a result of crossbreeding of Asian and African rice for higher yield potentials. It is grown by smallholders for income and household consumption. It occupies 95,277 hectares of land. Rice statistics and status. Uganda's annual rice production is approximately 350,000 metric tons. Rice yield in Uganda is 2,800 kilograms per hectare, both irrigated and rain-fed, as you can see in the graph. Global variety of rice is 4,700 kilograms per hectare. Then sub-Saharan rice yield potential is 9,200 kilograms per hectare irrigated and 7,000 kilograms per hectare rain-fed. Demand exceeds production. That shows that demand exceeds production in Uganda. Annual net milled rice import is around 62,000 tons. And that is in 2015 to 2020. And rice is mainly imported from Vietnam, Pakistan, Tanzania, and Thailand in Uganda, and its cost is 25.2 million annual. So let me call upon my other colleague to take us through the problem statements.
I'm Arinda Sophie, taking us through the problem statement. So there is a problem of food insecurity, and it is one of the leading global challenges because the population within the world keeps increasing by the day. So we believe that leveraging current technology and data collection, we can help the world to address the problem. During the cultivation of rice, a lot of data like weather data, rainy and sunny season data, soil textures, amounts harvested, fertilizers used, and also different cultivation techniques. This data is collected and it's not properly used. And since the data is not used, someone cannot make informed decisions which lead to the proper crop yields harvest. So we believe that if this data is well organized and clean, it can be used to predict better crop yields and help in better and informed decision making by the farmers. Like, for example, if a farmer knows the perfect season and once they know the season that is coming, the kind of soil texture they have, and maybe they will be able to tell which kind of technique they can be used at that particular season that is in that works together with the kind of soil, that is being that is within that area, so that can improve the crop yields. And if the crop yields increase in number, then we shall be able to solve the issue of food insecurity within the country. So that's it for the problem statement. Thank you.
Hi, I'm Nathan. I'll be taking to the next two parts, which is objectives and related works. So our main objective is to develop and test a deep learning model that can accurately predict rice crop yields based on various environmental and agronomic factors. So we identified other specific objectives that will assist us in keeping in line with the main objective. One is to identify the performance and effectiveness of the artificial neural networks basing on so as to achieve a certain rice crop yield production. So this is basically to identify the degree to which these artificial neural networks are able to achieve this rice crop yield production. Then another one is to use deep learning to identify the patterns and trends of crop yields. So for example, let's say we have a given period of time, it's a two given periods of time. And the first one, the trend is increasing, and the next one, the trend is decreasing. So this deep learning will help us to understand the factors that are responsible for the rise and falls in these given trends. Another one is to develop a machine learning based decision support system to optimize crop management. So this helps farmers to make the best decisions, ranging from pre-production of this rice to post-production. Then related works. These are basically various projects around the world that inspired project of ours. And one is a decision support system using artificial neural networks to predictive rice production in Phimai district in Thailand. Another one is Connectera IDS. So Connectera is basically a company that whose aim is to make sure that dairy farm operations are more efficient. So they developed an idea, which is like a combination of advanced AI with sensor data to learn the behavior of these dairy cows and farmers so as to make these farm operations more efficient. Another one is a deep learning based framework for automatic fruit recognition in Gilgit, Baltistan region in Pakistan. So thank you. And
my name is Banjira Mark, and I will take us through the remaining session of the presentation. We shall start with our research questions. Firstly, how accurately can a deep learning model predict rice crop yields based on environmental and agronomic factors? And second, how effective are artificial neural networks in crop yield prediction? What are the patterns and trends in rice crop yields over time, and which factors are most strongly correlated with yield variations? Our research methodology. These were the steps that we took as we were undertaking our research project. I will briefly take us through each of the processes that we went through. During the data collection phase, we focused mainly on 18 districts, 18 rice growing districts in Uganda. And we collected information concerning rice growing in all the mentioned districts, for the different seasons and for the years ranging from 2000 to 2017. In the data pre-processing stage, we then clean the data in order to organize it according to the years and the seasons, and also to make sure that we had no missing values or incorrect values. And we also did label encoding, where we are able to recognize which features were to be selected. And in the next stage, which is the feature extraction, we picked out the features, the key features which we are going to use, which we considered as key features that influence the crop yields. That is the precipitation, the maximum temperature, average and minimum temperature, the soil factors as well, the area under production for each district, the production for each district, and the yield for each district for all the mentioned years. We then went on to select our algorithm, where we selected the multi-layer perceptron algorithm, which is a supervised feed-forward artificial neural network. We then were able to split the data into test data and training data. And this data was then fed into our training model for where we are training and evaluating the accuracy levels of our model. In conclusion, there is a lot of evidence for the need of better decision support systems to predict rice crop yields, as enabling farmers and giving them insights on the crop yields can help them make more informed decisions about the next seasons and during the farming season. We were also able to come up with a model that could be used by expanding on the data set and also on a wider study area in order to efficiently predict the rice crop yields. Our limitations: we were limited by the inaccurate data, as very many different sources where we were collecting our data had different values for different regions, and this gave us a problem. Another limitation that we experienced was we had to eliminate some factors, such as government policies, because we were not able to properly implement these factors into empirical data, and such factors could have a significant impact on the crop yield for any given district. And in the future works, as more and more smart farming techniques and devices are being realized around the world, proper integration with these systems can help improve on the prediction accuracy of the model, and integrating the model with these systems can also help the farmer in proper management and maintenance of their farms. Thank you very much. This was Group 17.